This is worksheet 8.5. We're talking about exponential growth. So number 1A will do. It says in 1990 the cost of tuition at a state university was $4,300. The tuition increases at the rate of 4% each year. Every single year the cost is going up 4%. So we're going to use our exponential growth model down here. And remember that one of the big things is to make sure that when we have 5% or any percentage that we write it as a decimal by dividing by 100 or moving the decimal point, which is right there, 2 to the left. So our initial investment goes in for P, that's 4,300, parentheses, 1 plus, that's always there for exponential growth. And then the rate of increase was 4%, which is written as 0.04. And we raise it to the amount of time or the number of years that it grew by 4%. And from 1990 to 2010 is 20 years. So it's raised to the power of 20. And you should get, so you punch this all into your calculator. And if you're like, oh man, how do I get that exponent written up there in my calculator or my Google calculator, which is what I'd recommend you use, or download a good free scientific calculator. You use the X to the Y button right after the parentheses to get the number up there. Or if your calculator does not have that button, look for this button instead. And when you use this is called the caret key. When you use the caret key, the 20 that you write after it won't actually show up as an exponent, but if the caret symbol is in front of it, your calculator will know that you mean it as an exponent. Your final answer there should be $9,421, and we'll round to the nearest cent, so 83 cents. Number 2, we'll skip to, you buy a house for $130,000. So houses are investments. Sometimes it pays off, sometimes it doesn't. It appreciates at 6% per year. How much is it worth in 10 years? All right, so our initial investment was $130,000. That goes in place of P in our equation. We always have a 1 plus because it's growing. And then our rate is 6%, so 0.06 raised to the power of 10. So your final answer there is going to be $232,000, $232,810.20. Let's try number 4. You invest $2,040 in an account with 5% interest for 15 years. How much money will you have? Using that same formula right here. Think about what numbers go in where. 2040 will go right here, parentheses, 1 plus 0.05. Our percent goes there as a decimal and then raised to the power of 15. For this you should get about $4,241 and a penny. Number 5, you invest $475. You know what? You can probably do this one. Oh, I'm going to do it. $475. That's our invested amount. It pays 8.5% interest each year for 12 years. How much money will you have at the end of the 12 years? So 1 plus, now here's where we've been making mistakes. I'm going to go off to the side here. I don't see this mistake happen if it's 8%, but people do not like this 8.5. If you're into dividing by 100, do that to get your decimal. If you're into moving the decimal point 2 to the left, do that. This is the decimal point, folks, right here. So we need to move it 2 to the left. 1, 2. So the decimal point ends right there, or is right there, and a 0 needs to go in there. So 0.085. If you were thinking 8%, like if the problem changed and it was now 8%, a lot of people are like, yeah, that's 0.08. So yeah, it is. Now just throw the 5 after the 8. Right there, like we have. And it's raised to the power of 12. So your final answer is $1,264.30. Now, this doesn't just work for money. In this case, in number 6, we have 100 frogs, and they increase at an annual rate of 22%. How many frogs will there be in 5 years? So every year, the number of frogs increased by 22%. So we're still talking exponential growth here. So now it's just not money, it's the number of frogs. 22% looks like 0.22 as a decimal. Raised to the power of 5, we'd have 270 frogs. Ribbit, ribbit. See if there's any toughies here. I think the ones on the back should treat you all right. Use this graph to determine when a house will be worth $350,000. So this graph, let's read it. It talks about the value of a house on the y-axis, and on the x-axis is the number of years that you've owned it. I guess I read into that a little bit, but the number of years after it was assessed at $250,000. Looks like the value's been going up over time. So when is it worth 350? So go to 350, go straight across and hit the graph. Ooh, right there is where it's worth 350. Now I call this the rectangle method. Drop down to the time, and that will tell you when or how many years afterwards it will be worth $350,000. So we'd say in 16 years, it'll be worth $350,000. Same idea for part B. Go to $400,000, arrow over, hit the line that shows the worth of the house over time, and now drop down as straight as you can. Looks like 22 or 23 years. And do the same thing for part C. Yeehaw!